Welcome back to another session of Kubernetes and Cloud Native series. And today it's going to be very important from an administration and security point of view. And we will be discussing how to secure accessing your Kubernetes cluster using RBAC. We'll understand some of the different ways in which you can secure that API access, and then we'll integrate that access with AWS IAM with it, right? Because since we are using AWS, we would want to utilize, and see if we can integrate some of the inbuilt capabilities of AWS security and user management with Kubernetes cluster. Because if we do that, that will be awesome. Why it's important? Because if you don't care about securing your Kubernetes cluster, things like this happen. Now, this is an example, I think, from February, where Tesla's Kubernetes cluster, you can read it here, was hijacked because the console or the API was not secured. I think it wasn't even requiring a password or anything. Remember, once you have access to the Kubernetes cluster, you can pretty much do whatever you want on that cluster. Depending on the applications which are deployed there, you can go and access entire AWS account from there. Your masters are very powerful in Kubernetes cluster anyways. They have a lot of full credentials, right, or full privileges for your EC2, your VPC, your S3, your IAM. So this is why it's very critical to secure your Kubernetes cluster properly. And we'll discuss and understand what are different ways in today's session. So I'm Praveen Salitra, engineering lead here at Innate. We talked about what Innate is in the last few sessions. We had understanding of what kind of applications we are developing here, platform we are playing with here. Ultimately, we love the word and the phrase Dockerize everything. So let's go. And today is going to be focusing on access security, and then sessions from now on will be on how to deploy stateless applications or workloads, stateful load balancing, disaster recovery, and some other cool stuff. I already have the recording for the previous session last week that I uploaded, and then it also has command references for everything that we used in order to install locally or run apps locally. How did we install it on AWS using KOps, some of the privileges that you would require, and buckets and cluster, different variety and configuration. So I have put everything there for you so that you can go ahead and play as well. So let's go ahead and then start with access security. So what are questions for today? Today we're going to be answering, first of all, what is Kubernetes API? And then once we answer that, we'll understand how to make it secure or how to access it in a secure fashion. We'll understand what are different ways in which Kubernetes has support for access security for that. RBAC is one of them. We'll understand how, as a human, you can talk to Kubernetes API, but also how you can access API server from your services, from your applications, because that is also important. Nodes have to authenticate themselves as well to the API server. So there is a concept called service account for that, and we'll understand that as well. And then how we simplify it, all this configuration of security and management using AWS IAM. We'll understand that. What if you have multiple Kubernetes cluster? If you are an admin of that kind of DevOps team, you will have multiple clusters that you will be playing with at the time. How can you securely access each one of them from your same machine without altering or changing your files or configurations or anything like that? So these are the questions we will try to answer today. So the first thing I just want to do is we have that cluster that we configured last time. I'm just going to open the cluster.yaml file. I changed a few things. I just want to deploy it. So by the time we reach halfway mark of this particular session, we have the cluster up and running. So I have the cluster.yaml. It is created in the same fashion as we understood last time. The only difference is this block of authentication, and I'm going to be using an integrated module which is available from KOps for AWS. How it works, all those kind of details we'll see towards the later part of session today. But apart from that, it's just a single master, single node cluster. So there is only one master, and there is only one minimum node. Maximum size I have put it as 2, but it will be creating only one at this point, and it has one bastion as well. Nothing more than that, because again, today we are just talking about API server. We just need to understand master. So let me just go ahead. Academy folder. Cluster.yaml is already there. Let me just go and set up few stuff. I want to make sure I have the cluster name there. I'm putting the bucket which was already created last time, if you remember. I have already created bucket and the versioning and the user and everything. I'm just gonna go ahead and create the environment variable for the KOps state store. And as soon as I'm done with it, Yep, I have one of this configuration. I'm just gonna go ahead and create the cluster. So it's ready, it's saying, okay, do yes command or flag, and then it will ask for me to pass over my SSH keys to the EC2 instances, and then I'm just gonna apply this command again. So it will start deploying the cluster, assuming that everything will be fine. Let me just cross-check my AWS account just to see if some things are coming up. Instances are coming up. VPC is also created, so we are good. I think by the time we come back after understanding RBAC and security and everything, the cluster should be up and ready. So this is the diagram that we have been looking into, right? For the last few sessions, we understood what are different components in a Kubernetes cluster. Now, if you see here, most of the stuff is already in VPC, right? Your masters, your nodes, assuming your load balancer as well, if you are on AWS cloud for that matter, right? These things are already in the VPC, and you have, let's say, solidified or hardened your security for your load balancer. The only problem that I see here is this arrow. Why? Well, because as I said before and described in the previous sessions as well, kubectl is very powerful because it is accessing Kube API server. That means if you have proper access and authorization, you can pretty much dismantle or work or administrate your entire cluster from your machine, from your laptop, right? And that's the arrow that we will be trying to harden today, the security against. So that's the whole point of the session today. So let's understand, first of all, what is Kubernetes API, because there are so many things around that concept today. So Kubernetes API is an HTTP-based API with JSON as its primary serialization schema. It also uses protobuf for the internal communication. From external perspective, we just need to worry about its JSON schema. Then everything in Kubernetes that you all create into Kubernetes, maybe it's a pod, a deployment, a service, a daemon set, a job, whatever you have, they are all treated as an API object, and it has a corresponding entry in the API list. We'll see today once our cluster is up and ready. Also, Kubernetes follows the standard as far as the API documentation is concerned, and it has support, and it is going to follow Open API spec there. So definitely we will have something like swagger.json coming out of this API. So let's go and look into it. There are a few things that you should be knowing about in Kubernetes world, specifically after understanding the Swagger and the specification of it. There are a few things related to versioning. Kubernetes actually supports multiple API versions, backward compatible new features, all those kind of stuff. So you may see something like V1 or V1 beta 1 or alpha 1. So it supports alpha features, beta features. Just whoever is developing that API has to make sure that to use proper version scheme or naming convention there as well. And then, of course, if it's stable enough, you will see V1, V2, those kind of notations there. It also has a concept of API groups. So it has grouped most of the API into V1 section, but then there is a separate group for extensions. There is a separate group for any other custom stuff or APIs that you want to create. So it has implemented a concept of API groups as well. By default is enabled. And that's one of the things with the Kubernetes API. Let's go and see if the cluster is up, because I want to showcase the swagger.json from the API. So master is not there. We'll come back to it. Now in Kubernetes world, we will in few minutes from now also deploy something called a dashboard. Kubernetes has created this dashboard which allows you to have view of the entire cluster. Depending again your access credentials here, you can access it, and then you will be able to see different kind of resources, resource utilization of your nodes, your cluster in terms of CPU and memory, and you can drill down to detail until the logs of that particular container as well. You can see your secrets there that you have created for your services, networking configuration. If you have some persistent volumes on your EBS or EFS type of storages, you can access and control everything from there. So looks like master is up. Let me go to the API. So if you check your Route 53, KOps, while installing Kubernetes cluster, has already created an entry for the API server. And right now, API server is accessible from outside cluster as well. So api.kubernetes.inet.academy, and it's gonna be on the HTTPS. And it's gonna present me with the self-signed certificate. I'm just gonna accept it. And now it's asking me the username and password. So by default, it is secured. One thing important here is, okay, where is my username and password? So when KOps was installing Kubernetes for you, it has created this kube config, right? We'll go into detail today, but if you open it, down there is a basic auth credential that I'm just copying right now, and the admin is the name of this user. And here, as soon as you authenticate, you can see different type of API groups available to you. So this is the core API group, API v1. Most of the stable things are available here. And then you have a lot of other stuff as well, including anything related to authentication, some of the apps, some of the API extensions, some ABAC policies, RBAC policies, storages. They have the health endpoint as well. And then this is where you can find the entire OpenAPI spec as well. And it's a large JSON file, so it's going to take a lot of time to load this. And think of it like a typical Swagger.json. If you want to understand it, load it into a Swagger UI, and you will be able to understand what the heck these endpoints are. So since our API server at least is available, I'm just going to wait for the node as well to come on board. We need node because that's where any workload will be deployed. Nothing is deployed by default on masters. Forget about why this is not healthy. We'll come back and understand what this piece is first of all. But at least right now our master and node are ready, so we can actually deploy dashboard. So we have already checked the API. I'm just going to deploy this dashboard whose definition and all the objects required to deploy are available on this YAML configuration. It has a secret, a service account it will create, a role it will create. We'll understand all these things today. Role binding, and then ultimately the deployment from this particular image, and then a lot of networking configuration about the health and all those pieces, and then ultimately a service so that you can see it from the outside. So I'm just going to use a command to apply this configuration to my cluster, and that will create all the necessary components, whether it's secret, service account, deployment services, everything. And if I check pods again, well, I should be checking into the kube system because it's a Kubernetes components. Let's check the pods, and you can see dashboard should be somewhere here. It's coming up, it's running right now. So let's go and try to access it. By default, Kubernetes API server, since last couple of versions, it has stopped making this dashboard available from your API URL like this. Instead, what you can do is you can open up a proxy using kubectl on your local machine. I'm just gonna go and open this proxy here, and then it's gonna proxy internally from your local machine to the Kubernetes cluster on this particular port. And then once you have that ready, on that particular localhost 8001 provide you access to the dashboard. Let's just go and understand what is this piece. So here it's gonna be asking for the credentials, right? And this time credentials are different that you have to use. Kubernetes dashboard is secured, and in order to understand where you can find that token, or at least the kube config, the token in this case we'll try. There are many service accounts that you have, or secrets that it has created. One was, you remember this guy? Right? And then a lot of this others as well. So those things are already created, and since you are the admin, just for the time being, we can go and check all of the secrets in the kube system, and there are a lot of them available. These secrets, think of as passwords, tokens, JWT token, bearer token, certificates, a lot of that stuff, which will allow you to access Kube API server in some capacity. So you can see some will let you allow talk to AWS cloud provider, the CCM part of it. Some will allow you to talk to only the daemon sets or understand only the daemon sets. Someone will allow you to talk to only the pods garbage collector. Some security credentials will only allow you to let understand nodes, namespaces, and all that. I'm just going to use this one because this is one of the most powerful one. By default, there is no admin credentials created for the Kubernetes dashboard. You can go and create it, but not recommended from my perspective. I'm just gonna limit it to this one. Describe. Okay, this is encoded, so much better. So once I am authenticated to the Kubernetes dashboard, again, this is not running locally. kubectl is just proxying it from your local machine to the real Kubernetes cluster running on AWS account. So Here I can see different namespaces. I can see all the two nodes that I have. One of them is a master, other one is just a node. I do not have any persistent volumes. There are some default roles already created, some default storage classes. And then we can also see some namespaces, and in those namespaces we can see all the pods. Of course, one of them is failing right now. We'll go and fix it later down the line, but a lot of stuff. You can pretty much go and access all those things from here. Maybe you want to go and check the logs as well. You have access to those, and you can check the logs of all the pods running in your Kubernetes cluster from this dashboard. Pretty powerful. Make sure you have proper access to it. The Tesla story that I was talking about, yeah, this is what it was. It was running in public without a password. I think they were using an old version of Kubernetes which did not have RBAC enabled by default. Now it is enabled by default. So you can get a sense of everything from here. You can even go and create a new kind of resource available either by pasting your YAML file or JSON file as well in that case. So a lot of good stuff you can have access from this dashboard. If you want to understand more variety of access control for this particular dashboard, or what if you want to create an admin account just for the dashboard, there are a few roles and role bindings that you may want to create and give full access to the dashboard. Because even right now, I cannot go and access settings because that's not allowed for what user I'm using right now? Namespace controller token. Using that token, I'm only allowed to access some of the resources, not all. And by default, there is no admin sort of token or access credentials set up already in this Kubernetes cluster. Okay, so let's go back. So that was the dashboard. And one thing you can see here, different type of objects you have, right? And important thing you understood here is this namespace, or at least saw a concept called namespace here. So question is why there are few things in the cluster scope like namespaces, nodes, persistent volumes, roles, and storage classes. And then a few things are in the namespaces, right? So what is a namespace? Big question. We talked about it briefly in the last session, but let's understand it fully today. So think of namespaces as virtual clusters backed by the same physical cluster. In this case, this is the physical cluster, same, right? With one node and one master, and inside it we have multiple namespaces. So the same concept as I talked about in the first point. So they are just the virtual cluster. Ultimately, under the hood, they are all running together and logically isolated or separated on the same physical cluster. Another thing why you would want to use namespaces more often, because it allows you to have resources uniquely identified or scoped within a namespace. So you can think of namespaces very easily as you can use them like your environments. Maybe you have a dev environment, you have a staging environment, you have a prod environment. You can separate or create maybe 3 namespaces like that. Just giving you an example. Maybe another situation is you have multiple teams and they all want to use your Kubernetes cluster. So instead of creating different clusters for different teams, you can just create one large physical cluster and create namespaces and lock those teams into their own namespaces so that they can't access someone else or some other team's namespace. Same thing you can use for the environments as well. There are 3 default namespaces that we saw just on that dashboard. One was default, other is kube system, other is kube public. So the default is when you deploy an application or a pod and you don't specify a namespace, it goes and gets created into the default namespace. There's nothing more than that. You can't delete any one of these 3 default namespaces available from Kubernetes kube system. This is an important namespace because that's where all of Kubernetes specific objects, resources are created. So everything related to the kube router or the DNS or etcd cluster or even your API server, they are all running here, right? So ideally only admins should be having access to the kube system namespace. Then there is something called public. The whole point of providing a public namespace in Kubernetes is just to allow a possibility of exposing some application, some object to everyone, including unauthenticated users, if there is a requirement like that. Again, in our experience, we have not used kube public, or we haven't seen any useful feature coming out of kube public namespace anyway. So, but these are available there, and you can create your own more namespaces as well, and then you can lock security for your users, your developers, your applications, and tie them to specifically to a few namespaces. So we'll understand one kind of example today. As I said, namespaces allow your admins to set access control per user, per role, or even resource quota per environment. Think of a scenario where you have one large Kubernetes cluster, and then you want to limit how much CPU and memory your resources in one team can utilize, right? You can pretty much lock down and say, you know what, this particular namespace should be using 0.5 CPU of the entire cluster and only 1 GB of RAM total, right? Something like this. So you can control resource quota as well as security or who can access what within a namespace. Namespaces hidden from each other, but they are not fully isolated. A service from one namespace can talk to other service in other namespace. That's enabled by default. If you want to restrict it, you have to create network policies, which will not go into discussions today. So you have to make sure if you are using namespaces for environments, you pretty much configure network policies as well. Otherwise, it might end up your dev applications are talking to prod applications as well. If you can control it, fine. It's pretty easy to use namespaces for environments. If you can't, then just create separate clusters, at least for your dev environment. So coming back to service talking to other service in other namespace. So each service has a DNS entry in kubedns using the name of the service .namespace.svc.cluster_local. This is the cluster specific internal DNS. You will not be able to reach out to this cluster from outside, but just internally. Pods, your services can talk to each other, including across namespaces using this format. So maybe something like you have an API microservice in the dev namespace. If you want to reach out via canonical name, it will be api.dev.svc.cluster_local. Maybe the same API is available in prod as well. You can have something like this. In this case, dev and prod are actually the names of namespaces. Because of this, you can have API deployed twice, or API microservice or API pod deployed twice in this particular fashion, because your namespaces are giving you the scope for that particular isolated cluster or virtual cluster. So that's a namespace, to be precise. Now, another thing before we start understanding RBAC is how many types of subjects can be there requiring access to the Kube API server. One of them is humans like us. When you access the cluster, for example, using kubectl, you are authenticated as a user account. For example, in the previous, when I was talking to Kubernetes Dashboard, I was using admin credentials, right? So that was a user account. The other way is the service account. When processes inside pods, they try to access the cluster, including, for example, kubelet, they are authenticated as particular service account. Now here, if you remember, all of this are service accounts created internally for different sort of controllers, right? This particular application wants to talk to the Kube API server, and depending on the access here or access level, it can actually get access to a bunch of resources. Here, it's entire namespace. This guy is gonna be able to talk to API server and only get access to nodes. This is only going to be accessing persistence volumes and nothing else, and all those kind of things. So these are via service accounts. So if a human needs to access the cluster, that's a user account. If a pod or a container needs to access API server, that's a service account. As simple as that. Once you understand that, let's understand, okay, what are different steps in this authentication, authorization, admission control process, entire process before you reach to the end resource, whether it's your pod, your namespace, your node, or whatever these things are. So it doesn't matter whether you are a human user or a service account. There are a few layers that you have to cross before you reach to your objects. And the first thing is the TLS. You remember this thing again? Remember, this is actually on TLS, right? Although it is giving you self-signed certificate, but that's how it is enabled by default. So it will be serving you on port 443, that means HTTPS, and it will be presenting a self-signed certificate. And you will be questioning, where is the root certificate for that? That's actually already available in your config. So when KOps created cluster for you, this is actually the root certificate that even API server is using for that TLS certificate generation. So this is just the certificate. There is also a counterpart called key, certificate key, which you have to make sure that it's secured, because if you let both the certificate and the key, the private key out, then pretty much you lost everything. You don't have control over the Kubernetes cluster. Anyone can provide any sort of access to anyone else, any other user. Certificate is fine. These are meant for the public sharing, but private keys are not. And that's why you only see certificate here in this case. So the first hurdle is the TLS. And by default, Kubernetes will make sure your API is getting served on port 443 with a self-signed certificate. The next step is the authentication. And here, Kubernetes wants you to identify yourself, who you are, right? Forget about whether you can access this particular resource or not, because that's the authorization. In this case, we are talking about who you are. Probably you will give me your certificate, your private key authorization. Maybe it's just a password, maybe it's token, some other type of tokens for the service accounts, the one that we have already used to log into the dashboard. Yeah, something like that. So there are different variety of available methods that you can have to authenticate yourself or for the service accounts as well. And if you see the config when I open, right? So this is your cluster. Then we'll come back to the context and everything, but this is what I'm talking about. So when KOps installed this cluster on AWS, it actually created the certificate for you, this particular user, and also created its key as well, right? And this is the private key, which should not be shared with any other user, even in the same DevOps team. How do you onboard a different admin onto the same cluster or give access to him or her? We will understand that, but by default, KOps will create one user for you. Otherwise, how will you access your own cluster? It will also create an HTTP basic authentication token for you. So this is one way of authenticating to the API server. Present your certificates and the key, right? Now, one of the problem with this particular point here is with the certificates specifically, it's pretty powerful, better than, of course, the basic authentication. But then it's very hard to manage if you have more admins in your account. So that's where Kubernetes provides authentication webhooks where you can plug any other authentication module and Kubernetes will take help of that. And one of them is what we'll be using later down the line today called aws-iam-authenticator. Now, the next step after you cross the hurdle of authentication, identifying who you are, the next thing is authorization. Can you access the resource you are talking about, right? So this particular module or step will evaluate everything that you have in the request against all the policies that you have already put on your server and whether you should be allowed or denied for this particular API endpoint. Maybe you are trying to access pods in a specific namespace. Are you allowed to access pods in that namespace? Yes or no. If you are not, it will be sent as 401 or 403. There are multiple authorization modules here, ABAC, attribute-based access control, or RBAC, role-based access control, which is what we'll be using today. There is a webhook mode as well, and there are some default roles and other things created by default by Kubernetes. So just go and quickly understand this as well. So when your request is going through those three steps, you have the subject, meaning who you are, which group you are belonging to, right? It already knows what API endpoint you are talking about or whether you are making a request to. Then it also knows about what HTTP verb you are using there, right? And then what you are trying to access, whether it's a pod, deployment, service, secret, certificate, a lot of other stuff. So you have a bunch of this information, and that's how you can configure using pieces of this information, whether it's a subject or the object or the action, and then you can configure your rules and access policies around it. There are a few authorization modules. One of them is ABAC, which is going to be very specific to the user. For example, here, this is one of the ABAC policy. And here we are saying, well, for user Alice, she has access to all the resources in all the namespaces, right, belonging to all the API groups. In case of Bob, the user has only access to pods in a specific namespace, only the read-only access, nothing more than that, right? So you can see ABAC works around policies, and these policies are with respect to the individual users. And that becomes very hard when you have a lot of users to play with. Right? You need to actually have SSH access to the master. You need to have root file system access as well on the master VM. Also, anytime you want to make changes in your policies, maybe a new user is coming into your team or someone is leaving, you have to restart your Kube API server. So it's very hard to manage ABAC, and that's why entire community wants to go forward with RBAC. So what is RBAC in that case? So on ABAC side, it was tying to specific subject, right? That's why it's very hard if you have a very large team. On the other hand, RBAC deals with the roles. And if you can assign people or users role, at least you can limit configuration, permutations, and combinations there. Maybe you can create a developer role, a DevOps role, an admin role, those kind of roles, and you can assign users with these three roles. At least you know that, okay, most of the people or in your team will be on the developer role, so you don't have to restart your API server or manage them, unlike the ABAC world. So that's why RBAC is preferred, and entire Kubernetes community is focusing or going towards RBAC. So in this case, there are four concepts which are very important. RBAC, role-based access control. One is role itself. Think of it as a definition of action and the object. For example, here, a role is an object or a definition in Kubernetes world, which is specific to a namespace. So here we are saying we are creating a role called pod reader, for the namespace default. What it allows? Well, it allows doing get, watch, and list type of operations on the pods. That's it. So that's a role definition. So there is another thing called cluster role. The only difference between a role and a cluster role is tied to a namespace, while cluster role is actually cluster wide, meaning it's not tied to a specific namespace. Why? Well, because there are a few things in Kubernetes cluster like nodes. Yeah, they are not tied to namespaces, or like these endpoints like health, or maybe your persistence volumes, which are attached on your nodes again. Those are not tied to any namespaces. Those are cluster-wide scoped. So in that case, there is a same definition you can create, but this time you don't need namespace attribute there, and that becomes a cluster role. So what is a role or a cluster role doing? It's allowing you to define what can be done with these resources. The missing point here is who, the subject, right? Because role and cluster role both are allowing you, okay, in this case, anyone who has access to this role or is assigned this role can do get, watch, and list on secrets. Here, anyone who has access to this particular role can do get, watch, and list on the pods. But who part is controlled via bindings. So if you have a role and you tie it with a subject, that becomes a role binding. If you have a cluster role and you tie it with a subject, that becomes a cluster role binding. Pretty easy to understand if you know the basic concepts. Role, cluster role, role binding, and cluster role binding. So in this case of role binding definition, again, same stuff. You have name of the binding. You tell it, because again, role binding is specific to the namespace. Cluster role binding is specific to nothing. It's for the cluster-wide scope. Here you are saying the user Jane has been assigned a role pod reader and for this particular namespace default. That's it. So this is where the binding happens between role and the subject. Now, subject can be individual user or it can be a group of users as well. Here, there's another kind of subject called group, and there you can assign the entire group. Same thing goes for the cluster binding, just that there is no namespace there, but the rest of the stuff still aligns. For example, here, we are binding the role called secret reader, which it was creating before, and then saying anyone who is in the group manager, bind them together. So any user who is in the manager group is assuming the role of secret reader, and that is a cluster role, meaning you can read secrets across cluster, right? Across namespaces in this entire cluster, because that's a cluster role. So those are the 4 things that you have to make sure you understand, and that's it. There are a few roles and role bindings already available for you. Just to make things simpler, those are already defined. We will get and understand a few of them in a few minutes. The last part is, what if you want to validate the request payload, right? And you want to provide some pluggable controller just to validate, or maybe set default values before it reaches the final objects, right, or the persistence. So that's admission controller. You can have some sort of mutation, maybe putting default values on it, on the incoming objects, or maybe validating it, right? And as the action suggests, this is not going to work on the read objects or read endpoint. Admission controllers are only going to be effective whenever you are trying to create, delete, update, or even connect, but not for the read. As I explained, you can also use it to set some default values. For example, default storage class. These are some default admission controllers available, or limit ranger. For example, you are creating a pod and you do not specify any resource quota on it. How many CPUs your application needs, you don't specify it. You don't specify how much memory it would need. So if that's the case, you can create a default limit as well, saying, you know what, if someone is not specifying the resource quota, I'm just going to assume by default it's going to consume 0.1 CPU or 0.01 CPU and 10 MB RAM, something like this, and you can set it. And this admission controller will take care of setting those default limits for you. Default storage class is another example when you want to create a persistence volume. We'll understand in 2 sessions from now. If you want to create a persistence volume, but you don't specify the type of volume you want to create, whether it's EBS or EFS, this guy can handle the default storage class for that. So those are some of the examples. And there are some default admission controls as well. So just doing a recap, RBAC. It's a method of regulating access to the computer or network resources based on your roles and not on the individual names. If you do it the other way, that's ABAC. And we understood 4 types of objects: roles and cluster roles, role bindings, and cluster role binding, right? This is where you define action and the objects. In this case, you tie the roles with the subjects, and that's the whole point we discussed in length. RBAC is enabled by default from 1.8 and higher. In Kubernetes, right now it's 1.12, so we are well above that limit. It should be preferred to use RBAC over ABAC because managing RBAC is much more easier compared to ABAC, because if your users leave or your admins leave the team or come in the team, and if it's a very large team, it will be very hard to manage using ABAC. So, demo time. We talked about a lot of this stuff. Now the question is, how do you manage your all this cluster access? What roles have access to what? What if you are the admin but you want to provide only the read-only access to the dev namespace for your dev team, but other admins should have the admin access and all this kind of stuff? And where do you write and configure all this stuff? So as far as the configuration is concerned, there is a file called kubeconfig. Again, there is no file that you will find with this name, it's just the concept. So it's a file, configuration file, where you can find all the stuff, including what is the cluster, what is the user, and what's the context you are trying to access. And if you already notice, it's this file, which kubectl will use to create or access to your API cluster. And this is present in your home.kube folder, and that's a config which is created by KOps for you first time. If you are not the admin who created Kubernetes cluster, you have to ask someone to create a user for you, and then you will have probably a similar file on your machine as well. So everyone needs their own file, configuration file, or kubeconfig file to be precise. What it provides, so it tells me where is my cluster, what is the certificate of the cluster API, and then where is it, so API server, what is the name of it. Then you have users defined there. Now in this case, since it's using certificate-based authentication, you cannot share this file with someone else, because this is like sharing your passwords to some other users, other admins, other folks in your team. So you cannot share this. There are steps that you can have to create a user if you just want to follow the certificate way, which is, okay, what if, let's say, you created the Kubernetes cluster, but you want to provide someone else access to the cluster as well, but not sharing with your private keys and your certificate? You will have to create certificate for the other users as well. And that you can do. I have list and linked the steps here. So you create a private key for them using OpenSSL. You then create certificate signing request using OpenSSL again, using that private key. Then another important thing is the admin who created the KOps cluster, meaning whoever has access to this S3 bucket, you need to sign that CSR for that particular user using things which you already have available. You need a CA, certifying authority of your cluster, certificate, as well as the private key. So you can use those two files. So this is where you have the certificate available of your cluster, which is exactly same as this guy. This can be shared and public. The other thing you would need in order to certify other new user is this private key, which is in PKI/private. You go there, and this is the private key. This thing should not be shared with anyone else. And that's why it's painful to work with those things, because then you have to somehow smuggle that private key into your local as well, and then the new user who is coming into your team, giving his private key and the CSR to you, you have to sign it using the CS cert and CA key, and that will create a new certificate that this user going forward can use in his own kubeconfig like this. So ultimately, you will be creating a new certificate data or new certificate file for the new user, as well as the private key which he has given to you. Right. So it's a very cumbersome process here to go through this particular way of onboarding new users to your cluster, and we want to simplify it, and that's what we'll try to do using aws-iam-authenticator. We used to use this for almost 6 months before switching on into aws-iam-authenticator. That's pretty easy, and it's actually the module which is even used by Elastic Container Service for Kubernetes, which is official managed service from AWS for Kubernetes. Now, it works nicely with aws-iam credentials. It uses this service to create temporary tokens called STS behind the scene for you, and then it hands it off to Kubernetes cluster. Nowhere you are creating your private keys or certificates. Internally, it's going to use IAM credentials or your AWS access keys and AWS secret access keys to authenticate to the Kubernetes cluster. Again, it helps you in avoiding to manage your separate credential provider, and then removes the pains of signing the certificates for the new admins, new users for your Kubernetes cluster. Remember this piece? Yeah, this sort of work you don't have to do if you go ahead with this particular module. And as I said, this is used by EKS by default. So how it works? You have your AWS CLI running on your machine, right? So you talk to STS, which is AWS service, and that authentication is done using your AWS CLI. So you are using your IAM credentials behind the scene. So you tell STS to give you a temporary token for this particular cluster. You have that token. You then shoot it to kubectl. kubectl will pass that token that you just got, which has 15 minutes of time span, and then you pass it over to kubectl. kubectl will send it to kube API server. Now you run one more component here on the API server, which takes this token that you just got from the STS and then sends it back to IAM to figure out whether you are a real AWS authorized user or not. So this is IAM again. So what do you need? You need two things. You need some setup on the local machine to talk to the STS whenever you do kubectl, blah, blah, blah. And then you need some component on the API server which can take or extract that token coming from the kubectl request and confirm it with the IAM as well. And once it's done, confirmed, then looking at the roles and whatever role bindings you have for that particular user, it can allow you or block you accessing the resources. So that's a very pluggable and intelligent way of handling your users or credentials. So that's what we're going to be doing and setting up today. So you need some setup, and most of the setup is one time. Once you have set all these things on IAM, either you can do it from UI or AWS CLI. You have to do two things, as I said. You have to make sure you set up something locally, but also on Kube API server as well. This setup is one time. This setup is one time. There are a few steps, and again, as I said, they are mostly one time. So first of all, you have to create a role in your AWS account. So I'm just going to go to IAM. So you go there and you create a role, because ultimately when you say or you talk to STS, which is your secret token service, you say, well, am I allowed to assume this particular role? So you have to create that role. So let me go and create a role. I'm just going to say, okay, this is my AWS account, which you can find out here. I'm just going to go there. You have other options as well if you want to make sure the users, whoever is assuming this role, have to have multi-factor authentication required and all that. I'm not going to select those. I don't have those things set up for this particular account. So I am putting my account ID for this particular role that I'm creating now. I don't have to select any permissions or anything. I am just going to name it. So what is it? Academy. I'm just going to call it developer, right? That's the whole point. I'm creating a developer role. Same thing here as well. And this is just an object that I want some users to have access to it. What this object allows you to do, it's not defined yet, right? It's not defined here in this case. So it's just an object that we have created on IAM, and we will ask STS to confirm whether the users you have on this machine can assume this particular role or not. So that's the only piece here. Once that is created, which was very simple, the other thing you have to create is as a policy, because if you want to assign these users, whatever users you have, if you want to assign them certain roles, you have to create a policy. So I'm just going to go and create a policy. I'm going to say what service I'm creating this policy for. Remember this? STS. So I'm just going to select STS from here. And I'm going to asking for a permission called assume role. So once that is done, and I'm asking, okay, what is the resource? What resource you are asking for assumption, right? In this case, whoever the user has this particular policy, they want to assume a specific role, but what is the role? So if I go back to the role, because that has a unique ID of it, the role that I just created, where is it? This guy. So copy this and then just come here, add this ARN here. That's it. So you can see this is my account ID and this is the name of the role. So I'm creating a policy. Whoever has this policy will be able to assume this particular role, and that's what we needed, right? Review the policy. I can name the policy. Let's say this is this. You can confirm one more time what you're trying to assume and just create this policy. So far we created a role. Using this policy now, which we just created, we'll allow certain users to assume this particular role, right? That's the whole point we did. This particular, not the other ones. Ignore the other ones. Then you need to install some component on the server side. Now, if you remember at the start of this particular session, I talked about this guy. This has already installed that component on the API server. if I go and just do pods, this guy, it's just trying to start, but it's not starting because the configuration is not there yet, but at least the deployment is already done, right? For that aws-iam-authenticator, we just have to provide some configuration to that. And where is that configuration, or at least what is that configuration? So if you go and read the entire documentation of authenticator here, why it is required and how it is good, this is what we are doing: creating IAM role, running it on the server, which is already deployed. And if you scroll down after reading everything, there's some complicated configuration that you have to create, but it is one time only per role that you want to create. So I already have it. Let's just go through it. It's a config map, configuration for Kubernetes cluster. I'm naming it. It will be residing in the kube system, though it has comments as well. So the one thing you need is the ID of your cluster, which is, if you're using KEOPS, will be the DNS of the cluster, which is this. And then you can have as many as entries in this map roles array. Let's look at this. What I'm talking about here, I'm saying whoever has this particular role, consider him being in this group. So that's this mapping, right? The username here is just for identifying who that real user was. Doesn't do anything more than that. The important things are, what is this role? And if you remember, this is the exact role that we just created, this guy. So this is the role. So here in this case, I am saying whoever says to you, Kubernetes, that he has this role, assume that he is part of this group. What are the capabilities of this group? We'll talk about it here. This is the role binding here. I have created one more, but I did not create a role. You can always try. Here I'm saying the admin role, right? So instead of working with this certificates, even for your admin, you can actually create role, dedicated role in your IAM as well. So you can safely delete these things later down the line. So in this case, what I'm saying, whoever presents itself to Kubernetes API server saying you have assumed this role, that particular user is in the group of system masters. System master is the most powerful group. It's an inbuilt group in Kubernetes, which is cluster admin. So we have these two things created. You can have as many as roles that you can map here. Maybe you can have a developer, a DevOps team, maybe a read-only, whatever you can think of. Make sure they all have roles created in your IAM. And then I have another object in the same file, same YAML file, and this is the role binding. What is it doing? It's saying whoever belongs to this particular group. You remember we previously already configured that whoever says to API server that he has this particular role, assume that he belongs to this group, right? And now we are saying whoever is in this group, make them the admin of this particular namespace. Right? We don't have this namespace. So let me go and create this namespace right away. What is it? Dev or development or dev environment or whatever you want to call it. Let's see how many namespaces do I have now. So I just created one more namespace. So what I'm doing now is I'm saying the developer, whoever has this role, should be able to do anything in the dev namespace. Of course, he will not be able to see outside dev namespace, but within the dev namespace, he is admin. Right? So it's kind of giving an admin permission for the dev environment for your developer, whoever has this particular role. What is this admin? What are the capabilities of this guy? This particular cluster role. And again, this is already defined. So if I go and do cluster role, these are already defined cluster roles. And one of them is admin. So if I just describe on it, you can see what this particular role can allow you to do. So you can do all this type of operations on all this type of objects. So pretty powerful. And these are some roles which have been created for you by Kubernetes by default. So you have an admin, you have a cluster admin as well, you have an edit role which allow you to edit a lot of resources. And there is something called view as well, which will only allow you to view or read certain resources, nothing more than that. So maybe let's say you want to allow your developers to only view production but not do anything with else, right? So you can possibly give the view access to prod namespace using the same concept here. You can just have one more binding object with production namespace or whatever it is, and then you can just say view in this case. And they will only have view access. What it can do, you can see. They can only do get, list, and watch. There is no create, delete collection, execute, patch, anything, or update. They can just see whether the stuff is running or not. So this way allows you to use RBAC in a pretty good fashion. So we have this configuration. I have saved it in the same file here. And if I go back and check, my pod is still not coming up because it doesn't have that configuration. I can check the logs to see it's failing to find the configuration. Just waiting to start. There is no configuration there. So what I'm gonna do, I have saved it as a config map. Again, remember what we are doing here. You have a cluster ID. Make sure you have unique ID to identify your cluster within your AWS account. What can be better than the DNS? And then I'm mapping multiple roles. You can map multiple roles to the groups, and then you can define role binding for each group in this case. If you want someone to have admin access to the entire cluster, just attach them or combine them into the system masters. It's an already created group, which means cluster admins superpowers for your Kubernetes cluster. So once that is there, I'm just going to apply this configuration. What is it? It's going to create the config map, and then it's going to create this role binding as well, this piece. And then I'm just going to check if this pod is still coming up or not. Since it will not come up like this, I'm just going to go and delete this. And since it's part of a daemon set, it will automatically come back again, right? Someone is trying to schedule it. I'm forcefully deleting this pod. The daemon set, which is responsible for making sure this pod is always up, will schedule it again. So let's go to pods. And now it's fine. It got its config map because I already created 2 steps back. And it's running here. If I do logs again. So everything is up and ready. So that was the part where we configured the server side. What do we need on the local machine? Few things. So again, we didn't need to do all this updating the cluster because we already deployed aws-authenticator using this command. So I'm skipping this. This we have already done. What you need is a binary called aws-iam-authenticator. This has been written in Go, so you have to install it and compile it and then make it available on your path within your command line or your terminal. So you have to make sure you have Go available, and then once you have Go, bring this code for the aws-iam-authenticator and then install it. It will install it as well. So ultimately, this piece is going to be available as a binary. And of course, make sure that you also put the path into terminal path. I have already put it in the path, so make sure it's available there. And then the only thing we have to do is, you remember this config? Previously, it was using certificate to authenticate to the cluster, right? We do not need it anymore. Instead of using certificates or passwords or anything, we can also create a new user, and this time we ask kubectl to actually execute a command on behalf of us. You remember this binary that we just installed using Go? Yeah, we can tell to use this authenticator to talk to STS, get that temporary token first, and then pass that token back to the Kube API server. So I'm just going to copy this format and put it into our config. I'm just going to create a new user actually at the end of it. So this is the user. I'm saying instead of asking for any certificate or password or anything, just execute this command, pass these parameters because we are talking about this particular cluster, and try to assume this particular role. Again, this is the developer role that I'm trying to assume in this case. Now, one thing will be very handy to you. What if you want to switch between multiple contexts from a developer to an admin or maybe to multiple clusters? You can do that using this nice thing called context. You can mix and match your clusters and users. So one is already available here. I'm just going to create a new entry in the context array, and I'm going to call, yes, for this cluster, for the dev namespace, whenever this user is asked for, try to authenticate for this particular namespace in this cluster. So this is new context so that I don't have to worry about individually making sure I'm using this user or this user or this user. I can just easily switch context. That means if I'm in this context, I will be a developer. If I'm in this context, I will be an admin, right? And how do we switch those things? Easily. I have a tool called JX on my machine, which can easily go and switch context, which is just, so right now it says current context is this, right? I'm gonna change it manually to this particular context and become or present to Kubernetes as a developer only. So yeah, it's all erroring out right now, although the context has changed. I am a developer right now and only have access to dev in this case, but it's not letting me access to the cluster. I'm trying to do get pods, but it fails saying 403. So what did we miss so far? We have downloaded aws-iam-authenticator. We have deployed and configured our server-side component. We have created roles and policies and everything. I have my AWS credentials on my machine. The only thing I'm missing so far is the user here is not assigned that policy, right? So that's why it's failing in this case. I'm just going to go there, and it's an existing policy that I created. So I'm on my user, and I'm just going to attach that policy to this user. So I'm giving this particular user an ability to assume a specific role. Let's see if that works out. So it still fails because there is one more settings that you have to do. The thing is, you can have this role in a different AWS account as well. So just attaching a policy to a user doesn't mean anything. On the role side, you have to allow that user as a trusted guy. Right now, only the root user is allowed here. So I'm going to edit the trusted relationship of this role as well and say, you know what, this user, yeah, allow him to assume a role. So I have to do both sides. One side is not sufficient because whoever has admin account on this AWS account can actually go and create any policy. And what if this role was in a different AWS account, right? Maybe you have multiple accounts for your customers or your environments. So now that I have done both sides, I have given the policy to the user, also configured the user into the trusted entities for this particular role. So both sides are done. And once that is done, I can see I am developer role right now in this case, and I can't access anything, but can I access cluster scope resources? No. If I try to access nodes, which are in the cluster scope, it says it's forbidden. What if I try to access maybe other namespaces? Namespaces are also in the cluster scope. I can't access it. I'm only blocked or logged into this dev namespace. And if you go back to the definition here of this particular role binding, I can pretty much do anything but within the limits of dev namespace, right? Can I go and deploy a pod or an application within the dev namespace? Let's try that. I have this engine exploit, so let's see. Yep, I can do that. Can I get pods? Yeah, I can do that as well. I can get secrets as well, as long as I am within the namespace, right? Within the dev namespace in this case. So that's how you can restrict certain users depending on IAM and this particular configuration for the RBAC. And you can pretty much secure your cluster in whatever way you want. Now, going forward, you just have to create your IAM users and start assigning them this policy. And in the rules, just start adding them into the trusted relationship as well. These are the only two things you have to do for your admin team, and you don't have to worry about certificates and private keys and any deployment on the server side for this or restarting the server side. So in this case, it's pretty easy to do all this stuff once we understand this particular pluggable webhook based authentication module. If you have multiple cluster, in this case, where is our config? We have multiple users, right? But you can also see that you can have multiple clusters as well. This is an array. So you can create a new cluster, add or append it here as a new cluster. And then you can mix and match and play with multiple context, multiple users. You have ability to merge all of those multiple cluster configs into the same thing. Another important thing right now is if you get rid of this too. Now there is nothing in this file that you cannot share with anyone else. You can share this particular file if you remove those certificates, because now we are using just the aws-iam-authenticator. So it's safe to commit to the Git or even share to your team. Because again, remember, there is no certificate or private key for a user, right? It's just asking, can you assume this particular role? And internally, it's going to use your AWS credentials, AWS CLI credentials, and nothing related to your certificates. This certificate is anyways supposed to be open. This is the TLS root certificate for your API server, not the private key. So you are fine. That means you can share this entire kube config on your Git, and then anyone can just download it. As long as they are provisioned for your users and policies and roles here in your IAM, you can pretty much do whatever you want. So I have this tool called JX to switch between multiple contexts easily. If I'm using multiple clusters or I want to assume multiple roles, this is pretty easy to change it here as well. It also allows me to change to namespaces in an interactive fashion. So I can do those. There's another tool called kubectx available on GitHub. You can install that as well. And kubectx will also allow you to change context as well as namespaces. You can install JX or kubectx from these links. But if you want to do it pure command line, then this is how you do it. So that's what I had for this particular session. And in the next session, we will understand how to deploy a stateless workload. That means pods, deployments, services, how to do service discovery, how to figure out number of replicas or replica sets, at least on the stateless workload side. So that's going to be the target for the next Thursday. And that's it for today. So thanks for joining.